So today let's see the summary of the second module. Okay, module 2 summary 21 ELN 24. Okay, so the second unit started off with your logic gates, different gates. Okay, so if I make a table of gates, symbols, truth table, and Boolean expression. So symbols, truth table, and the Boolean expression. So starting off with what are the different gates we have studied. So the first one is your buffer. Okay. So the buffer. The symbol of your buffer was was your output, y is your output. So what was your truth table? Input x, y. So you had two combination, right? Either it will be 0 or either it will be 1. Buffer is when output is equal to your input. So your truth table will be always equal to the output will be always equal to your input. So your Boolean expression is equal to x is equal to y. Okay. The second one was your inverter. So in the case of inverter, you had a small bubble onto your output. So whatever may be the input, the output is going to be your inverted form. So it is called as x bar. So what is your truth table? So if I have x input y 0 1 2 combination, if 0 is your input, 1 will be your output. If 1 is your input, 0 will be your output. So your output y was equal to x bar. Okay. Now third one was your AND gate. Okay, so what was your AND gate? So this is your symbol of your AND gate. Here I am giving it two input AND gate. Okay, so if I take A as input and B as the other input, so your output will be A into B. So what is your truth table of your NAND gate? So since you have two inputs, so you will be having how many combination? A, B and Y. So what are the different combination you have? 0 0 0 1 1 0 1 1. So you have totally 4 combination. Okay. So wherever you have 0, the output will be 0. 0 into 1 0. Only when both the input is high, you will be getting the output as high. So what is your output? Y is equal to A dot B. Okay. Now your fourth one was your OR gate. Okay. So the OR gate, what was your symbol of your OR gate? A, B is your input, Y is equal to A plus B. Okay. These are the basic gates. And OR. Okay. And NOT. Now what is your truth table? Similar to that of your AND gate, A, B, Y. So 0 0 0 1 1 0 1 1. So wherever you have input as 1, you will be getting the output as 1. When both the inputs are 0, you will be getting output as 0. So Y is equal to A plus B. Okay. Now what is your fifth gate? Fifth gate is your NAND gate. NAND gate is nothing but your inverted form of your AND gate. So you are going to just give a bubble. A, B in the output side. So Y is equal to A dot B the whole bar. So what is your truth table? The opposite of your AND gate. A, B, Y. Okay. So what is your output you are getting? 0, 0, 0, 1, 1, 0, 1, 1. So what is your output AND gate? 0, 0, 0, 1. So what will be happening in your NAND gate? It will be 1, 1, 1, 0. When both the inputs is high, your output will be low. Y is equal to A dot B the whole bar. Now what is your sixth gate? Sixth gate is called as your NOR gate. Okay. NAND NOR, that is nothing but your universal gate. So opposite to that of your OR gate or complement of your OR gate, A, B, what will be your output? A is equal, Y is equal to A plus B the whole bar. So what is your truth table? Again you have here four combinations, 0 0 0 1 1 0 1 1. So what is your OR gate? It is 0 1 1 1. So what will be your NOR gate? 1 0 0 0. When you have both the inputs as low, you will be getting the output is equal to 1. Y is equal to A plus B the whole bar. Another two gates which you have is called as your XOR gate. So what is your symbol of your XOR gate? XOR gate is equal to, okay, XOR A, B. So do you remember the expression A bar B plus A, B bar? Okay. So what was your A, B, Y, 0 0 0 1 1 0 1 1. So what was your output of your XOR gate? When both the inputs are same, you had the output to be 0. Okay, different inputs, you had the output to be 1. Y is equal to A bar B plus A B bar. So how did you write that? Y is equal to A XOR B. This was your symbol. Now one more gate which is called as your XNOR gate. So opposite of your XOR gate. Okay, XNOR gate. So the same symbol, if you give a bubble in the output, it is called as your XNOR gate. Usually it is given by the signal A XNOR B. Okay. So what is your truth table opposite of your XOR gate? So A, B, Y, 0 0 0 1. Let me write the other combination here. Okay, so let me write the truth table for XNOR gate. XNOR gate truth table. Okay. So A, B, Y, 0 0 0 1 1 0 1 1. So it is opposite of your XOR gate. So wherever you have inputs as same, you will be getting the output is equal to 1. Other case you will be getting it as 0. So what will be your expression of your XNOR gate? Okay, A bar, wherever you have 1, right? A bar, B bar plus AB. Or I can write that A XNOR B. Or I can write that A XOR B the whole bar. So these are the three ways in which I can express your different types of gates. Okay. So the next topic what you have is called as your bistable. So what are the different types of bistable? You had studied through, three different types of bistable. So let me write the different bistable, the diagram and the truth table. Okay. So what is your first bistable? First bistable was your RS bistable, right? So the RS bistable can be again divided into two types. It can be formed using NAND gate and NOR gate. So first one, let me write using NOR, right? NOR RS bistable. So the NOR diagram, what will be your NOR gate bistable, which consists of a feedback, right? So here you will be having the feedback. To this you have one your R and the other input will be your S. The other input to the S will be your feedback from the previous. So in the case of RS, in the case of NOR gate it is Q and Q bar, where in the case of the NAND it is going to be opposite. Okay. So the other feedback will be going like this. Okay. So R stands for reset and S stands for set. Okay. Now what is your truth table of your RS latch or RS bistable? So here it is Q. How many combinations you have? Since you have 2 bits, you will be having 4 different combinations, 0 0 0 1 1 0 1 1. So in the case of RS bistable, 0 0 will be no change, right? 0 1 means set is equal to 1. So Q will be equal to 1. If reset is equal to 1, Q will be equal to 0. Okay. So when it is equal to 1 1, it is also called as the race condition. Race condition. Okay. Now second one, using NAND. NAND RS bistable. So what was your diagram? So this, you had two NAND gates. You are replacing the NOR by means of NAND gate. And the only difference is what? You are going to change the position of Q and Q bar. Here it is Q bar, down it is Q. Yes. Now you had the second input coming from as a feedback, and you had the next input vice versa. Okay. Now what is your truth table in the case of NAND gate? It is opposite to that of your NOR gate. R, S, Q. 0 0 0 1 1 0 1 1. So 0 0 will be your race condition in this, right? Race condition. 1 1 will be the condition where you have no change. Now when R is equal to 1, that is reset is equal to 1, Q will be equal to 1. When set is equal to 1, Q will be equal to 0. Opposite to that of your NOR RS bistable. Okay. Now you have the next type, that is your D bistable. So how was your diagram of your D bistable given in your textbook? It had a clock pulse. It is also called as delay or data flip-flop. Okay, rising edge clock. So the input, transient input data, D, and Q will be your output data. So what was your truth table? So if I can make a truth table, X, Y, 0, 1, right? Input, if input is 0, output is also equal to 0. If input is Y, output is also equal to Y. But under what condition? You had a time delay. Okay, if this is your data input and if this is your clock pulse, okay, so clock. Now depending on the clock, you will be getting the output. So this will be, your data will be delayed. Okay, this will be your corresponding output. And the last one was your JK bistable. So JK bistable, JK bistable. Let me make the diagram. I am drawing it downwards. So what will be your symbol or your logic diagram? So you are going to just add clock towards your using NOR gate. Okay, I am drawing. So first we will draw the RS flip-flop Q bar. So one input is your R, the other input is your S, the other input will be your feedback. Here also you will be having a feedback. Okay, now to this what you are going to add? You are going to add a clock. Okay, so you are going to connect to AND gate. So what will be your input here? It is K, here it is J. So this will be your clock. You will be having the third input coming from your feedback, right? So this is going to be your diagram for your JK flip-flop. Now what is your, this is your diagram. What is your truth table? The race condition is avoided here. So you will be getting JK, J stands for your S and K stands for your reset, right? So Q. So 0 0 0 1 1 0 1 1. So what is your condition for your RS flip-flop? Same. So here it is no change, 0 0, no change. Here this stands for, J stands for your set and K stands for your reset. So if reset is equal to 1, Q is equal to 0. If set is equal to 1, that is J is equal to 1, Q is equal to 1. So this race condition is avoided here. So you will be getting the toggle condition. So this is your improvement of your JK bistable. Okay. After JK bistable, what are the different topics you have? Next one is called as your data representation. Okay. So under data representation, you have studied, you are going to study basically three different representation. One is binary, which has a base 2 digits. Next one is decimal, which has 10, base 10, and the third one is called as hexadecimal, okay, which has base 16. Okay, so now let me draw the three data representation equivalent, okay, values: binary, decimal, and hexadecimal. So if I make a table, hexadecimal 0 to 15, so total of 16, right? So before going on to this data representation, you should know binary addition. What is 0 plus 0, what is 0 plus 1, 1 plus 1, and 1 plus 1 plus 1. So 0 plus 0 in binary it is 0, 0 plus 1 it is 1, 1 plus 1 is 2. In binary it is equivalent to 1, 0. 1 plus 1 is equivalent to 3, which is in binary, which is equal to 1, 1. Okay, so what will be the values? Binary 0, 0, 0, 0. Now to this keep on adding 1. Okay, so you'll be getting 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. What will be your decimal equivalent? 0, 0, 0, 0 stands for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Now what will be your hexadecimal equivalent? So from 0 to 9, it is similar to that of your decimal, okay? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From 10 to 15, it will take your alphabet, okay? A, B, C, D, E, F, okay? So these are your different data representation. Now going on to your next topic was your data types, right? So under your data types, what was the different data types? Had a table, right? So different data types, the number of bits, and the range of values. What was a range? Okay, what was the four different types? One is unsigned byte. Second one was signed byte. So if it is byte, it was 8 bits, right? Next one is unsigned word and signed word. So since it was word, what was your number of bits? 16. So what was your range? For unsigned byte, your range was 0 to 255. For signed byte, your range was minus 128 to plus 127. Unsigned word, your range was 0 to 65,535. And for signed word, your range was minus 32,768 to plus 32,767. Okay. So these are the different data types. Next one was your data storage. So in the case of data storage, what was the different types of main storage devices you have studied? One was called as your ROM, right? The other one was your RAM. So what is your difference in your ROM? What did it consist of? It had the program code and permanent data, right? Permanent data. So what is it called by another name? It is called by another name called as non-volatile memory. Why? What is the reason? Because data will not be lost. Okay. Now what was your RAM? What did your RAM consist of? It was a temporary storage device. Okay, temporary storage device. What did it consist of? It consisted of the transient data and variables used by program. What was the next name? Different name. It is volatile memory. Why? Volatile. Okay, memory, because the data will be lost when the power supply is switched off. Okay. So the next topic what did you have is your microcontroller system. So what was your structure of your microcontroller system? So the microcontroller system mainly consisted of your heart, which is nothing but your CPU. Heart, okay. Central processing unit, which was driven by your clock. The clock, which was nothing but your crystal oscillator. Okay. Next important part was your memory, control program, which controls all the functions. So your CPU was given to your input and output ports or interface, right? So across the output you had your output port, across your input you had your input port. So what was the devices connected to your input and output ports? So across the input you had switches, keyboards, 1 2 3 4 5 6 7 8 9, okay, special characters, keyboards. Second one was your different types of sensor, okay, LED, laser, etc. And the first one of the example is your switches. Now what was the devices connected to the output? Indicator, display unit, okay, LCD display. Next you had speaker or a release, okay. So this is your main structure of your microcontroller system. The next topic was your half adders and full adder, right? So mainly you had your half adder and full adder. So if I can make a table, half adder, symbol, logic diagram, expression. So what was your structure of your half adder? So you had half adder, two inputs, and two outputs, sum and carry, right? So how did you draw your logic diagram? XOR gate and your AND gate. Two inputs A, B and your AND gate. So this was your structure of your half adder. What was your S? A bar B plus A B bar. C is equal to A into B. So what was your expression? Logic Boolean expression. Sum is equal to A bar B plus A B bar or A XOR B. Carry was equal to A and B. Okay. Now what was your truth table? So you had how many combination? A, B, sum, carry, C out. So what was your different combination? 0, 0, 0, 1, 1, 0, 1, 1. So sum was, first case sum is equal to 0, carry is equal to 0, sum is equal to 1, carry is equal to 0, sum is equal to 1, carry is equal to 0. Last case sum was equal to 0, carry was equal to 1. So this was your truth table. Okay. Now the next topic was your full adder. So in the case of full adder, what was your symbol? So if I can draw overall diagram for full adder, it consisted of three inputs, right? A, B, C in and two outputs, sum and C out. Okay. So how was your logic diagram? So you had two logic diagram. One is the normal full adder using your gates, whereas the second was your full adder using two half adder, right? So let me go with the first diagram, the logic diagram. First logic diagram. So how did you get your logic diagram? You had three inputs A, B, C in. So this was by using the formula. What formula? Sum is equal to A XOR B XOR C and carry is equal to AB plus BC in plus AC in. You had another formula for carry also, right? C out is equal to, this is also C out, which is equal to C in into A XOR B plus AB. So you had two formulas. Now this logic diagram is using your first formula for your C out. So you had three inputs A, B, C in. So what is your first expression? A XOR B XOR C in, right? So you are going to connect these three to an XOR gate and you will be getting your sum. Similarly, next is AB. So first is AB will be connected to your AND gate AB. Second one is BC in. So B C in will be connected to your second AND gate B C in. Third one is AC in. A and C in connected to your third AND gate, and all these AND gate will be added to your OR gate, which will give your C out. So this was your first diagram, logical diagram. The second full adder was using your two half adder, using two half adder plus an OR gate. Okay. So what will be the expression? Full adder. What will be your symbol? So you had half adder 1, half adder 2. Our input was A, B. The output of your first half adder, sum was given to A XOR B, right? Sum is equal to A XOR B, which was given as one of the input to your half adder, and the second input was C in. Okay. Now this C from the first half adder will be given to your, to the C out of the next half adder. So output of the second half adder will be equal to A XOR B XOR C in. C out will be equal to A XOR B, right, into C in. Now when your this output and the C from the previous output is added together, you will be getting the expression of C out. C out, which is equal to A XOR B into C in plus AB. So this will be equal to AB. Okay. The same diagram now you can draw it using your what? Gates. So gates means replacing your half adder by your gates. So what will be your structure? Using two half adder plus OR gate. The logic diagram. Diagram 2. So now you are going to replace your first half adder by means of your XOR gate, which consists of two inputs A, B. Similarly your AND gate. So which will give your S and C out of the first case. Okay. So I can take this as your half adder 1. Half adder 1. Now the output of your S is equal to A XOR B. That will be given as your input to your second half adder, right? XOR, okay. And now what is your second input? Second input will be equal to your C in. C in, okay. Now this 2 will be given to your AND gate. So S will be equal to A XOR B XOR C in. What will be your AND gate? C out will be equal to A XOR B into C in. Now if I connect these two to your OR gate, you will be getting your C out, which is equal to A XOR B into C in plus what is the value of C out here in this case, which is equal to AB. So this will be your construction of your full adder using two half adder and a OR gate. Okay. Now what we have missed here is your truth table. So what will be your truth table of your full adder? So you had A, B, C in as your inputs and your sum and C out. So what will be your combination? You will be having 0 to 8 combination, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So what will be your sum and carry? 0, 0. Here it is 1. So sum is equal to 1, carry is equal to 0. Here also sum is equal to 1, carry is equal to 0. Here you have two ones, right? So sum is equal to 0, carry is equal to 1. Here again sum is equal to 1, carry is equal to 0. Here sum is equal to 0, carry is equal to 1. Now what happens here? 0, carry is equal to 1. Here sum is equal to 1, carry is equal to 1. Okay. So this will be your truth table. By this your full adder is also done. The next one what you have is called as your multiplexer. So what was your multiplexer? Multiplexer was a device mux which consists of n inputs. Okay. So 1, 2, 3 etc. up till n inputs and one single output. The output always depended on selection line S0, S1 etc. up till if I take it as SM. Okay. So you have M select lines. what was your input? Input n was equal to 2 power m. Okay. The example given here was, what was the example given here? 8 cross 1 marks in your textbook. Okay. So what was your structure of your 8 cross 1 marks? You had 8 inputs. 1, 2, 3, 4, 5, 6, 7, 8. So D0, D1, D2, D3, D4, D5, D6, D7. What was your output? Single output. What was your select lines? You had 3 select lines, right? A, B, C. Okay. So this was your structure of your 8 cross 1 marks. Now what was your truth table you had? So can I write it here? Truth table? No, I'll write it in a separate page. So the next one is your truth table. So what was the combination you had? A, B, C, and you have Y output. So the 3 combinations was 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So if 0, 0, 0, data D0 was selected, D1, similarly D2, D3, D4, D5, D6, D7. Okay. So this was your truth table. Now how was your Boolean expression? Boolean expression y was equal to a bar b bar c bar into d0, a bar b bar c bar into d0 plus a bar b bar c into d1 plus a bar b c bar into d2 plus a bar b c into d3 plus a b bar c bar into d4 plus a b bar c into d5 plus a b c bar into d6 plus a b c into d7. So this was your expression for your multiplexer. Now the next topic what you had was your decoder. So what was your decoder? Decoder. So what was your decoder? Few to many, right? If I take the input as 1, 2, etc. up till n, what is your output? You had 1, 2, 3, etc. up till 2 power n outputs. So n to 2 power n, that was your decoder. Okay. Output. So the example given for your decoder is 3 to 8 decoder. So what was your structure? Input was equal to 3 to 8, right? So input was 3 inputs, A, B, C, and your output was 8. 1, 2, 3, 4, 5, 7, 8. So what was your output? D0, D1, D2, D3, D4, D5, D6, D7. Okay. So how was your truth table? So this was your truth table. A, B, C, A, B, C. Let me start off with your most significant beat. D7, D6, D5, D4, D3, D2, D1, D0. So for your first combination, what was your data? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. What was your data for 0, 0, 0? D0 was selected. D0. Okay. 0, 0, 0, 0, 0, 0. Again D1. 0, 0, 0, 0, 0, 1. 0, 0, 0, 0, 1, 0, 0, 0. 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1 D5 0 0 1 0 0 0 0 0 0 1 0 0 0. Finally your MSB D7. Remaining everything was equal to 0. Okay. So this was your truth table. The next topic was your shift register. Okay. Moving on to the shift register. So you know that 4 different types, right? So if I can give you the structure, what were the 4 different types? Serial in, input, serial out, serial input, parallel out. Okay, so if I give here as Q0, Q1, Q2, Q3, this will be your parallel out. Parallel in, parallel out. So D0, D1, D2, D3. D0, D1, D2, D3. Parallel in, serial out, and parallel in, parallel out. So you can divide the types into 4 different types. One was SISO, SIPO, parallel out, parallel in, parallel out, parallel in, serial out. 4 different types. Okay. So the example given here was for both the types, all fuse diagram, right? So JK. So 4-bit JK register, shift register, both parallel as well as serial. So let me start with your serial operation first. So you had 4 flip-flop, 1 2 3. So J3, K3, Q3, Q3 bar, J2, K2, Q2, Q2 bar, J1, K1, Q1, Q1 bar, J0, K0, Q0, Q0 bar. What were the other things? So here you had a serial input given to the J, and inverted using a NOT gate was given to the K. Okay. So output of one flip-flop will be input to the other. Here you will be getting the serial out. Okay. Now you had a clear signal CR, 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 which was negative. Okay. So this stands for clear. Next, what is the next signal you had? A negative edge trigger clock pulse. Okay. So here you will be having clock. This stands for your clock. So this will be your structure of your serial in, serial out. To this, what you are going to add? You are going to add a preset enable, which will give you the parallel loading. Okay. So which will be connected to your AND gate. So first 1 2 3 4. Okay. This will be your preset enable. Now the other will be your data, which is loaded parallelly. So what will be your data? D0, D1, D2, D3. Parallel loading of the data. Similarly, if you want parallel output, so this will be your parallel output. So this will be your Q0, Q1, Q2, Q3. So this is your structure of your both your parallel as well as serial loading. Next topic what you had is your counter. Okay. So in the case of counter, what are the 2 different types of counter based on your clock? One is asynchronous. clock at different time, and synchronous, clocked at the same time. Then you had other two types, whether it is counted upwards or downwards. That is, one is up counter and another one is your down counter. Okay. So next let's go on to your example of your counter, the last topic, that is your 3-bit asynchronous counter. The example given was your 3-bit asynchronous up counter using JK flip-flop. So what was your structure? 3-bit means it counts from 0 to 7. So J0, K0, Q0, Q0 bar, J1, K1, Q1, Q1 bar, J2, K2, Q2, Q2 bar. Okay. So what was your characteristic here? It was converted into a T flip-flop, right? So the value of 1 was given to all J and K tied together. Okay. So your value 1 will go to your J as well as your K. Now you will be giving your clock input to your first flip-flop, CLK. Now output of the first flip-flop will be serving as your input clock to the second flip-flop. Similarly, the output of this will be given as input clock to the next flip-flop. You will be having a preset in addition. Okay. So Q0 output will be your LSB, Q1, Q2 output, Q2 your MSB. So this was your structure of your counter. Okay. So what was your table? So based on the clock, input clock, it works in toggle condition, right? We will be having the 3 outputs, Q2, Q1, Q0. So what are the different combination? So 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 clock pulse, it comes back to a 0. Now what will be your combination? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. It again clears to 0. So here we will be having totally how many transition? 1, 2, 3, 4 transition. 1, 2, 3, 4. But whereas in this case you will be getting 1 to 0, 2 transition, and here you will be getting only 1 transition. Let us see this using your clock diagram, timing diagram. So you will be getting, this will be your clock pulse. Okay. Negative edge triggered. So only clock will be triggered only during the negative triggering pulse. So if I take Q0, Q1, Q2. So your clock will be serving as your input clock will be serving as your clock for your Q0. Okay. So during each clock pulse it will get triggered. Your Q0 will get triggered. Okay. So if this is 1, 2, 3, 4, 5, 6, 7, 8. So you have 1, 2, 3, 4 transition. Total 4 transition. Now your Q0 will be serving as your clock for your Q1, right? So during negative triggering pulse, it will trigger Q1. So you will be getting toggling will happen here. So see here, you had how many transition? 2 transition. Now Q1 will be, the falling edge will be your transition for your Q2. It will be serving as a clock for your Q2. So here you will be having the transition. So it is also called by, you had 1 transition. It is also called by another name, frequency divider. Okay. So these are the different summary of your module 2. Okay. So you can log into my Telegram channel, Few Minutes Learning, for the notes which is updated. Okay.